Introduction to Python Programming, Module 1. Welcome to the course, Python Programming, from Beginner to Advanced. I am pleased to begin this journey with you as we dive into Module 1, Introduction to Python Programming. In this initial module, we will establish the foundation for your learning, exploring what makes Python one of the most significant tools in the modern technological landscape. Let's get started. What you will learn. In this first module, we will cover 6 key areas to build your foundational understanding of the language. We will start by defining what Python is and exploring its history and evolution since the late 1980s. From there, we will discuss what Python has become so popular by looking at its specific strengths and advantages. We will also compare Python to other major programming languages and examine its diverse range of real-world applications. Finally, we will conclude by looking at Python's vital role within the modern digital economy. Introduction. Python stands as one of the most widely used and highly regarded programming languages in the world today. Since its inception in the late 1980s, it has evolved from simple scripting tool into a powerful and versatile language used across nearly every computing domain, including web development, data science, artificial intelligence, and scientific research. Its success is largely due to an elegant syntax and a vast library ecosystem that makes it the preferred choice for both beginners and seasoned professionals. Ultimately, Python bridges the gap between simplicity and power, making it the ideal language for everything from your first script to enterprise-scale application. Now, let's look about the definition of Python. What is Python? Python is a highly level interpreted general-purpose programming language designed with an emphasis on code readability, simplicity, and expressiveness. It is dynamically typed, object-oriented, open source, and cross-platform, running seamlessly on Windows, Mac OS, and Linux. As you can see from example on the screen, a simple hello program or defining variable requires no complex type declaration. These key traits make Python an accessible yet powerful tool for any developer. Key historical milestone. The evolution of Python spans over 3 decades, beginning in the late 1980s when Guido van Rossum started developing it as a successor to the ABC language. Following its initial release in 1991, major milestones included Python 2.0 in 2000, which introduced garbage collection and Unicode support, and the major redesign of Python 3.0 in 2008. By 2020, Python 2 reached its end of life, and today, with version 3.12 and beyond, the language continues to dominate the field of AI and machine learning. Why Python is the world's most popular language? Several factors contribute to Python's global popularity. It is clean, English-like syntax reduces development time, while its versatility allows it to be used for everything from web development to cybersecurity. It is supported by a rich ecosystem of over 400,000 packages, such as NumPy and TensorFlow, and a community of millions of developers. Because it is free and open source, it remains in high demand across the professional landscape, consistently topping developer surveys. Python versus other programming languages. We have Python, Java, JavaScript, C++. The features. typing, execution, syntax, speed, best for. So Python, it is dynamic, interpreted, very simple, moderate, and best for data, AI, and automation. Then Java, it is static, compiled, verbose, fast, enterprise. JavaScript, it is dynamic, interpreted, moderate, fast, V8, web fronted. And C/C++, they are static, compiled, complex, they are very fast, system embedded. When compared to other major languages, Python's primary advantage is its simplicity, while languages like Java or C++ offer high execution speed and are excellent for system or enterprise applications. They often involve complex or verbose syntax. Python, being interpreted and dynamically typed, strike a balance with moderate speed and a very simple learning curve, making it the best choice for data science, AI, and automation. Application for Python. Where is Python used? Python applications are vast and varied. In data science and analytics, tools like Pandas, NumPy are used to analyze massive data sets, while TensorFlow and PyTorch power modern AI models. Frameworks like Django and Flask power major platforms like Instagram and Pinterest. Beyond the web, it is a staple in automation, scientific research, and cybersecurity for tasks ranging from web scraping to vulnerability assessments. What are the key contributions to digital economy? In the modern digital economy, Python is a primary driver of value creation, enabling organizations to run raw data into actionable business insight. It is a primary language for AI, research, development, deployments, reshaping sectors like finance and healthcare. Furthermore, Python skills command premium rates in the gig economy and expands employment opportunities for roles such as data scientists and machine learning engineers. It is truly an essential tool for digital transformation and global entrepreneurship. Python is clean, readable, and powerful. Let's look at the example. So Python is clean, readable, and powerful. To illustrate Python efficiency, defining variable and printing formatted output is straightforward and highly readable when compared to a language like Java, which may require 7 or more lines for a simple result. Python can often accomplish the same task in just 2 lines of code. This makes Python dramatically simpler and faster to write and much easier for teams to maintain. So here is an example of Python. Python career domains. What can you do with the Python? The career paths available to Python developers are diverse. You could become a data analyst, a machine learning engineer, or a back-end web developer. Other roles include automation engineers, cybersecurity analysts, and even Python instructors in corporate setting. Whether you choose to work for a major organization or as a global freelancer, Python provides the technical foundation needed to succeed. Do's and don'ts. Python first principle. Do use Python 3, never Python 2. Use meaningful variable names. Follow PEP 8 coding standard. Use virtual environment for project. Write doc strings to document your code. Test your code with unit test or PyTest. Use version control, which is git/git hub. Don't use Python 2. It is obsolete. Don't use single letter variable names like XY. Don't ignore errors message. Read them carefully. Don't install all packages globally. Use BEMV. Don't write code without comment or doctrines. Don't skip testing. Always verify your output. Don't copy code without understanding it. Future trends in Python. Python growing role in emerging technology. Looking toward the future, Python is central to emerging technologies like generative AI and large language model. It is increasingly deployed on IoT devices and edge computing platforms, and it remains the primary language for cloud automation on platforms like AWS and Google Cloud. We are even seeing Python used as the interface for quantum computing development. With continuous performance improvement in recent version, its role in tech will only continue to grow. In conclusion, this model has introduced Python as a powerful, versatile, and widely adopted language, exploring its history, philosophy, and professional application. This foundational understanding has prepared you for the technical exploration we will take in Module 2 through 10. Remember, Python is your gateway to the digital economy from your first line of code to a professional career. Thank you very much.